This video will be about probability. So probability is the likelihood something will happen. You're basically trying to predict the future and decide, is this a good decision or not? Is this going to happen? What's the chances it's going to happen? So, when you're finding the probability, you are looking for the number of ways what you want to happen can happen over the total ways it could happen. So what we want to happen, all the ways what we want to happen could happen over the total ways it could happen. Like when you flip a coin, let's say you're the one who picks heads. You want to say, well, on a coin, one side's heads, one side's tails. Heads is one option, tails is the other. So the one we want is heads. There's only one of those. Out of all the ways that it could happen is 2, so that's a probability of 1/2. You can also think of probability as a decimal or a percent, so we could use our calculator. So I think this is the calculator on the OGT. It's the Desmos Scientific Calculator. So it should hopefully look something like this. To plug in a fraction, they have a fraction button. You hit the 1 first, I think, and then the fraction button, and then the 2. And then you see the answer already on the other side, equals 0.5. So this is the same as 0.5, and to change it to a percent, percents you always multiply by 100, so you would have to know times by 100, and so that means we have 50%. So here's some example problems. Leroy has a number cube with sides labeled 1 through 6. He tosses the number cube 4 times. Each toss results in a 5. What is the likelihood that his next toss will result in a 5? So a number cube is basically a die. They said it's labeled 1 through 6. So they're trying to trick you with this, he tosses it 4 times. They just asked you what's going to happen next. They didn't say based off the tosses he's done. They said what's going to happen next. So on a number cube, only one side is a 5. There's a 1, 2, 3, 4, 5, 6. Only one of those is a 5. Out of there's 6 total sides. So that's a fraction of 1/6. You could do something similar, but this time when they roll the number cube, it still has numbers 1 through 6. What is the probability that she will roll an even number? So that's a little different. With just one number, there was only one possibility. With evens, you could have 1, 2, 3, 4, 5, or 6, and 2, 4, and 6 are all even numbers. So that's 3 possibilities out of the 6 total. When you're working with the fraction version of the probability, it will always be reduced. So to reduce a fraction, you think about what divides into the top number and also into the bottom number. So the only thing that divides into 3 and into 6 is 3. And then if you're using your calculator, only do the top separately. When you're reducing, we don't plug the entire thing in. So you can hit this enter button to go to a new line, or you could have erased the previous line. And you could type in 3 divided by 3. So the divide button also changes it to a fraction, but it still does the division. It shows you that equals 1. And then we do the 6 divided by 3. Again, we need a new line. So 6 divided by 3 is 2. So a probability of 1/2 of getting an even number. You can also be given a whole bunch of data and asked to find the probability from that data. So population data for Ohio is provided in the table below. And they have different races versus different genders, male or female, and then the total of everyone. All the white people, 9 million. All the Hispanic, 156. So based on this data, what is the probability, rounded to the nearest 10,000th, that a male selected at random in Ohio in 1998 would have been Hispanic? So some of our keywords, when we're looking at these problems, it helps to look for the keywords And the keywords here are male and Hispanic, and we're taking the probability. So we only care about the Hispanic columns and the male columns. Some of this table has useless information for this problem. It always depends on what they ask. So what we want is for the person to be a Hispanic male. So we go to our table and find that number. So a Hispanic male, there are 76,660, according to the data in the table. So then we have to say, well, what's the total amount? Based on the data, what is the probability that a male selected at random would have been Hispanic? So we only care about the total amount of males. They didn't say a Hispanic male would have been selected from the total population. They limited it to males only. So that's the 5,215,573. So all our answers are decimals. We're going to need the calculator again. We can hit enter to get to a new line. We don't need to put anything with the commas. There's no comma button. There's the decimal, but that's not the same as a comma. So we just type the number 76660 divided by 5,215,573, and it automatically gives us our decimal. There's only one even close, but you'll notice when they round to the nearest 10,000th, this 6 is going to round up to the 7 to match here with answer choice C, because the 9 next to it will force that 6 to go up. So our answer is answer choice C. So with these word problems, it's also good to just double check and say, did I answer the question? Is this the number of the probability you would select a Hispanic male out of all the males in Ohio? Some questions, there's multiple parts and you'll think you're done and you have to keep going. This one, we have answered the question, but you always want to kind of ask yourself that to make sure, did I answer what they wanted to know? So another example, Michelle picked a colored cube from a bag of cubes, recorded the color, and returned the cube to the bag. She did this 10 times. The table below shows the color of each cube as it was selected. Using the information from the table, how many times would a yellow cube be expected in 30 picks? So this time it did tell us to use the information from the table. We're not going to just do a probability. We're going to base it off the information given in the table. And we want a yellow cube in 30 picks. So right now we have 10 picks total, and we want to know how many of those were yellow. So we have 1, 2, 3, 4 yellow picks. Well, we want to get the total amount up to 30. So we basically want to keep repeating this table until we get up to 30. So if there's 10 picks, to make it up to 30 picks, we would need 3 of these tables. We would multiply by 3 to say 10 picks times 3 makes 30 picks total. When you do that, that's going to affect the yellows. That means we have 3 of these tables, all with 4 yellow choices. So we also multiply the 4 yellows by 3, which gives us 12 yellow picks. So again, did we answer the question? We found 12 yellow. Is that how many that could be expected in 30 picks? And it is. So our answer choice is C again. So last problem is going to involve geometric probability. A game has a circular target with radius of 12 centimeters on a rectangular board measuring 30 centimeters by 20. So we have circle with a radius of 12, rectangle with 30 by 20. Players win a prize if they throw a dart and hit the circular area only. What is the probability of a player winning? So there's 2 parts to this. if 35 people played the game, how many would you expect to win? So we have to answer both those questions. So it helps to draw a picture. It's a circular target placed onto a rectangular board. When they say the word radius, radius is from the center of the circle to the outside. So that's 12. And then it said it's 30 centimeters by 20. So with area, then we need to use some formulas. We want the probability of hitting that circle. So we want the area of the circle over the area of the entire shape. So I think you have a reference sheet to look at, but they're not labeled is what I've heard. So you may just want to start memorizing some of these formulas. The area of a circle is pi times the radius squared. And the area of a rectangle, because the total amount will be the rectangle, is length times width. So we want this area divided by the area of the rectangle. So when you use those formulas, pi times radius squared, we're going to plug in the number that corresponds. The number for the radius is a 12. The length times width, we have length is 30 on the rectangle and width is 20. So 30 times 20. So you could plug this whole thing into a calculator at once, or you could do just the top, just the bottom, and then do the division. So we need a new calculator line. We hit that enter button to get to a new calculator line. There is a pi button, so we can hit pi multiplied by 12 squared. When you do squared, squared is the little 2 up above. So a squared will get you squared. You could have also hit AB and then typed in the 2. When you hit AB, it puts you up in the exponent spot, and then you can type in your exponent. So there's the area of the top, 452.389. Area of the bottom, and so I did round. We don't want to write that entire decimal down, so I rounded a little bit. And then 30 times 20. Oh, and I didn't hit another line. So if you don't hit another line, then it's going to mess up. You have to hit enter, hit another line. 30 times 20 is 600. So now we divide. We need another line, and we do 452.389. I'm going to use a few more, plugging it into the calculator, and then divide it by 600 is 0.75398. So probability, you usually do 2 decimal places, because if you change it to a percent, most percents are going to be 2 numbers. So that 5 will remain a 5 because the 3 next to it is smaller than 5. So 0.75 is our probability of winning. In other words, a 75% chance of winning. You should be able to write it 0.75, or you could have written it 75%. So then there is a second question. If 35 people played the game, how many would you expect to win? If we take the 35 people and multiply by the probability, that will tell us the number of people that are expected to win. As always, make sure to go to a new line. I forget that a lot. 35 multiplied by 0.75, or you can just do 0.75, is 26.25. Now with people, you can't have part of a person, so we're going to round at the whole number. We're not going to say 26.25 people. We would expect 26 people to win. So that is our review of probability.